Hello maths fans. Today we're going to look at angles in polygons. And what are polygons? Polygons are any shapes with straight sides. Poly means many, gons is about the straight sides. So any shape with straight lines is a polygon. Now, with polygons, we can do all sorts of things to work out some of the angles. There are interior angles on the inside. If you think about the interior of a building, it's the inside. So interior angles are on the inside, and then on the outside we have exterior angles. Now these ones aren't quite as straightforward and logical, because exterior angles are made by extending lines and then finding that angle. It's not just that. That's not an exterior angle in maths. What we need to do is extend the line, and then this is an exterior angle. Extend the line, this is an exterior angle. Okay, and you might notice that they form a straight line. The interior and the exterior form a straight line, and that means they add up to 180. But we'll come to that a little bit later. Okay, here are two polygons. One of them is sort of more, I don't know, perhaps aesthetically pleasing than the other. And the wonky one at the top there is what we call an irregular polygon. It means that the sides are different lengths, the angles are different sizes. Down the bottom there, indicated by these lines, we have a regular polygon. So if all the sides are the same and all the angles are the same, we call it a regular polygon. And there are different rules for finding the angles in irregular and regular polygons. Let's start off with the irregular polygon. And let's think about finding some of the angles in this irregular polygon. I want to know what all of those angles add up to. This, plus this, plus this, plus this, plus this. Well, we've got 5 angles there, so this must be a pentagon. So that's helpful. But I can't exactly work out what all of those angles add up to. I do know that a triangle adds up to 180 degrees. And if you know that a triangle adds up to 180 degrees, we can use that fact in irregular polygons. So if I take one corner, one vertex, one point, and join it up to all of the other corners or vertices, join it up, it's already joined to this one, it's already joined to this one. You can see I've split that shape into triangles. And I know that this angle, and this angle have to add up to 180. I know that this angle, this angle, this angle have to add up to 180. And I know that this one add up to 180. So by splitting it into triangles, I've been able to work out what all of these angles must add up to. And in this case, it is 3 times 180, which is 540 degrees. 3 times 180, 540 degrees. So that irregular pentagon, what we did was we split it into triangles by taking one point, joining it to the others, finding out how many triangles there were. Let's look at some other shapes and see how many triangles in each of these shapes. Well, in the triangle, there's one triangle. In the square, if I take a corner, join it to all the others, I end up with 2 triangles. Let's just split up all of these shapes. So I've taken, very important that you just take one corner and join it to the others. If you get a bit carried away, I've seen people going, how many triangles are there? There's 1, there's 2, there's 3, there's 4. They just start joining everything up, and that doesn't help us. That's creating angles that we don't want to count. We just want to count the angles around the outside there. So, when I take one point and join it to all the others, you can see how many I get. Well, with the 3-sided shape, the triangle, I got 1 triangle. With the 4-sided shape, I got 2 triangles. With the 5-sided shape, there are 1, 2, 3 triangles. Here there's 1, 2, 3, 4. You'll probably spot a pattern here. 1, 2, 3, 4, 5 triangles. 1, 2, 3, 4, 5, 6 triangles. And there is a pattern to this. If we look at the link between the number of sides and the number of triangles that we've made, you should be able to see that it is, in fact, have you spotted it? It's 2 less, 2 less, 2 less, 2 less, 2 less. So if we know the number of sides of a shape, all we have to do is take away 2 to find the number of triangles. And if we want the total of all of the angles, what we have to do is we say it's the number of sides minus 2 times 180. So this bit here tells us how many triangles there are, and each triangle is 180. So we do 180 multiplied by the number of triangles that we split our shape into. Let's have a look at an example for this one. Calculate the missing angle P. We're going to calculate this one. Now, I could join up to all the other sides and work out that there is 3 times 180. Or I can spot that this shape has 1, 2, 3, 4, 5 sides. And so it is going to be... and so in this case, we're going to take 180 and multiply it by 5 minus 2. Because there are 5 sides. And we know that that formula, if I go back to my formula, the formula says take the number of sides, take away 2, times by 180. So the number of sides is 5, take away 2 is 3, so we're doing 180 multiplied by 3 is 540. That's the sum of the total of all of these angles. They all add up to 540. So if I want to calculate P, I need to do 540, take away this, take away this, take away this, take away this. And my calculation down there, 540 minus all of that is the same as 540 minus 430, and P was 130 degrees. So that's one way you can use this formula there of n minus 2 times by 180 to get the total of all of the interior angles. Very useful stuff. Let's move on to some regular polygons now. And there are a couple of rules for regular polygons. If we take this, another pentagon, it's a regular pentagon. Now, when I walk around the outside of a shape, or around the outside of anything, if I go all the way around the outside of something, I always turn through 360 degrees. Imagine starting facing this way, and then I'm going to turn, 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 and I get back to where I started. It doesn't matter what shape I go round. If you imagine walking round a shape, you've always turned 360 degrees when you go round the outside of something. Let's just have another little demonstration with this man. He starts there, turns through 1, 2, 3, 4, 5 turns, and he gets back to where he started. He has done a full turn. This angle plus this angle plus this angle plus this angle plus this angle, 360 degrees. Now with a regular polygon, these are all going to be the same size. All the exterior angles are the same. So to calculate one exterior angle, I've turned 360 degrees. I've done it in 5 equal parts, so I just divide that by the number of sides. In this case, that's 5. So let's have a look at that as a formula. One exterior angle of a regular polygon is 360 degrees divided by n, the number of sides. So if I had a 20-sided shape, I would do 360 divided by 20. And that would give me 18, I believe. Let's have a look at an example. Calculate one exterior angle of a regular octagon. Octagon is 8-sided. And if I wanted to calculate that, I would do 360 divided by 8, which is 45 degrees. And let's just picture that. There's an octagon, and there is a 45-degree angle. All of these exterior angles would be 45 degrees. Each one of them is 45 degrees. A little bit more information. Interior angles of regular polygons are very easy to calculate if you have the exterior. Because you can see, as we mentioned at the start of the lesson, the interior and the exterior angle, they make a straight line. And straight lines add up to 180 degrees. So if I have the exterior, to calculate the interior, I simply do 180 minus the exterior. And so in this case, we get 135 degrees. So that's another useful rule. The interior and the exterior add up to 180 degrees. Or one interior equals 180 minus the exterior. All right, 3 rules there. See if you can put them into practice in these 2 questions. I suggest pausing the video, and then I'll go through the answers in a minute. So pause the video, have a go at these 2 questions. And I'm going to go through the answer now. First one then, a heptagon, 7-sided shape. The sum of the interior angles, we use that first formula, 180 multiplied by n minus 2. And here, n, the number of sides is 7. And so we get 180 times 5 is 900. Part 2, calculate the interior angle of a regular nonagon. Well, for this one, we're going to do the exterior first, as 360 divided by 9, which is 40. And then we use the interior is 180 minus the exterior. And so we get 140 degrees. All right, hope you learned something there. That is interior and exterior angles in polygons. Thanks for watching.